we're going to look at another example. This is a second example. It's going to be slightly different. We might have a little bit of extra work to do on it, but as long as you understand how to calculate maybe inflows and outflows. But let's look at what we're going to see here. A company is considering buying a machine costing €135,000, which is going to be payable today, and we have the following 5-year projections in sales. Okay, notice this is in units. Okay, so unlike the previous question, you'll be able to look back on this later on, but unlike the previous question, I gave you cash inflows and cash outflows. Here, all I'm giving you is the years, the 5 years, and the sales for each of those years. Okay, your outflow is already in the heading there. The company is considering buying a machine costing $135,000. So you'll notice that in the previous question, I already had built in a negative inflow, or sorry, a negative outflow of 70,000 in there. So again, you'll get a chance later on to make a comparison between the two, and I'll separate these two parts out into 2 videos for you. Okay, this is new as well. We're told that a product costs €5 to produce and can be sold for €11. And the company requires a minimum return of 14% on all projects. Okay, first question, calculate again the net present value, whether the company should go ahead with the project or not. Here we have your costs and revenues, and now we have to calculate our net cash flows. Can anyone tell me how I got to 15,000 there in year 1? Just remember that figure, 15,000, a cost of 15,000 in year 1. Let's go back. Anyone tell me how I got to 15,000 for costs? Yeah, see, it says there the product costs €5. You have 3,000 units. So all my costs are going to be those units there times my €5. So that's how I got year 1, 15,000. So they'd be my outflows, cash outflows. My revenue then is going to be my inflows. So it's going to be €11 by 3,000. It's going to give me my 33,000. So you should see that figure in there as well. See the revenue of 33,000 in year 1. So I keep on doing that. So €5 by 7,000 is going to give me a cost of 35,000, and 11 by 7 is going to give me my 77,000, and they're the values there. So again, you can see hopefully where all those figures are coming from. €5 by my sales, €11 by my sales. They're going to give me my cost and revenues. In other words, my outflows and my inflows. And then I need to calculate my net cash flow. And if you recall from the formula, the net present value formula, if you recall the letter C in there, that's my net cash flow, which means it's my revenue minus my costs, or my inflows minus my outflows. And that's how I got my 18,000, 33 minus my 15, 77 minus my 35, etc. All the way to year 5, 121 minus my 55,000 will give us the 66,000. So I'm going to work with that. Set up my table again, like the way this is kind of familiar to you, if you recall on the last calculation. I have my years 0 to 5, my net cash flow. You see those values in there again, 18 to 66 from the previous slide. But I have in there a negative 135,000. Where's that negative 135,000 coming from? The negative 135 was featured in the opening sentence. That's my that's the startup cost, or that's my investment in the machine. It's going to cost me 135,000. So that has to be in year 0. Okay. So what I need to do is those blue figures are my C values that are going to be in the formula. The red there, the 1 plus R to the power of time, that, if you recall, that's your denominator in the formula. Or here, as I said, is 14%. So that's going to be 1 plus 0.14 to the power of time. And all you do for the power of time is put in 0 to the power of 0, then you go in power of 1 all the way down to power of 5 for each of those 1.14s, and you will get those figures. So say, for example, in year 0, it's 1.14 to the power of 0, which is always going to give us a value of 1. 1.14 to the power of 1 is going to give us our 1.14. And if you keep on doing that, 1.14 to the power of 2 to the power of 3, you're going to get all those figures. Again, if you don't like using the power of in your calculator, just get 1.14 multiply it by 1.14 again, and you'll get to 1.2996. Multiply that by 1.14, and you'll get the following figure, and keep on multiplying it by 1.14 until you get to the end, and you'll get to 1.9254. So in the formula, then we were told to apply 1 plus r to the power of time into your net cash flow, and that's all we're doing here. Okay, the 135,000 negative divided by 1, you'll see it's negative 135. 18,000 divided by 1.14, it gives you your 15 there, and etc. 66,000 in year 5 divided by the 1.9254 gives us your 34,000. Okay, they're your present values for each of those years. We're asked to get the net present value, which is you sum up all of those, and if you sum those up, you get a total of 67,732 euro, and that's a positive number. The last example when we did this, we got a negative number. Can anyone tell me whether we should go ahead with this project or not? Just know that if you get a positive number, you accept the project and the company should go ahead with it. And if you get a negative net present value, the company should not go ahead with it. All right, so we should go ahead with this now. The next part of your calculation would be to, and we're not going to estimate it with the graph. Okay, what I've set it up here is to calculate the internal rate of return if the discount rate is 30%. And the net present value at that is negative 2478, okay? So if it was this, the company wouldn't go ahead with the project, okay? But what we're trying to do is find out what the discount rate would be if your net present value is 0, okay? That's what we're ultimately looking for. So we have two discount rates. We had a 14%, which gave us about a 67,000 euro net present value. We now have a much higher discount rate of 30%, which reduces our net present value all the way into a negative, and that just means we're adding in a lot more risks. So 14% is relatively low compared to your 30, and if we keep on building in risks like higher interest rates, higher levels of inflation for the costs of our goods, risks in terms of the industry we're operating in or geopolitical, that keeps on adding to the discount rate all the way up to 30. And if those events happened, we would end up not going ahead with the project. Okay, so we want to find out with the IRR, what's the critical value? What's the discount rate that will tip us over into a negative? Okay, so that IRR is going to give us an NPV of 0. Okay, what I did was, by the way, please don't do this in the exam, what I'm showing you here on the screen. All I did was show you how to calculate that negative 2478. Very few people will actually go ahead and do what I'm doing on the screen here. Please don't do it because you're wasting your time. I'm actually giving you the net present value of negative 2478, but I'm only doing it here so if you just wanted to find out how to get the net present value all over again, okay, I'm just featuring here, I'm just confirming here that your total for net present value is actually negative 2478. Again, those blue values were identical to the previous one. All that's different here is what's in red, because instead of the 14%, we now have 30%. So you see your 1.3 in year 1. And if I keep on multiplying that by 1.3, you get all those values, dividing it in, and we get the net present value at the very end of the column. Okay, so please don't do this table again if you're given the net present value, which we are done. Okay, we're given it there at negative 2478. Just to let that be clear to everybody. Right. Here's your formula. Again, we've seen this already. We want to set up, find out what our two values are for the net present and also the discount rates. And that's here the summary of it. So in our first calculation, we got a positive 67,732 at a 14%, and we were given the negative 2478 at 30%. Please don't calculate that, it's given to you already. So plugging those into your values, okay, again, notice the negative numbers. Notice how I keep the negative number when its net present value is negative. So see that negative on the right side of the top line, we have a minus 2478. And on the bottom line, we have a minus 2478. I just do that so I won't make a mistake. That's all. You don't have to do it. But notice the basic mathematical rule, minus by a minus is a plus. So when we do that here, 67,732 by 0.3 gives you your 20,320. That there, 2478 by 0.14, it gives us a 347. Basic rule there. If you notice, minus by minus is a plus. So I should have a plus 347. Minus by minus gave us a plus. So I had a 67,732 plus my 2478, which gives us a plus 70,210. Right. So when we work through that, that's 20,667. divided by 70,210, and we get an answer that's very close to this figure here. So that tells us there that if the discount rate happens to be about 29.5%, it will give us a net present value equal to 0. And that's all you need to know. There's no real comment that you have to make. This is your typical exam type question. You were talking about maybe 18 marks out of 30 for this, perhaps 14 to 18 marks out of 30 for this, to calculate the net present value and to calculate the internal rate of return or do its diagram.
Okay.